Okay, trying to relax because I just ran here. My name is Glen Hinkle, as he said. I'm also known as Tempire. I'm a member of the core team of Mojolicious and the creator of the Mojolicious screencast series, Mojocasts. If you're a part of the community, you've probably seen them. I work in Orem, just down the street, and that's me. Okay. Oh, also, it's beautiful outside. I'm not really sure why you guys are here, but
we're not at work.
That's what I was. Okay. Me too. It turns out. Okay. So this is Mojolicious non-blocking web services. The why, the how, and the sequentially ordered. If you've been paying attention for the past couple of years, you know that non-blocking is the cool thing to talk about in web services. Node.js is popular for this. Some people say it's super fast because it's non-blocking. But in truth, any language can do non-blocking constructs or non-blocking given the right constructs. And it doesn't matter what language you're talking about. Even PHP, it turns out, can do it. I just found this out. There's a PHP non-blocking framework the other day. Personally, I choose Perl. Because it doesn't force anything on me. I can use objects. I can use functional style. I can do whatever I want. And Mojolicious on top, because it's hands down the simplest and most advanced framework available for Perl. So I'm going to be talking about some general concepts that apply to any language. Any framework that does non-blocking behavior, these apply to. And then I'm going to go into some details about the abstractions that Mojolicious provides to make non-blocking code more manageable. And the most important thing, I think the most important thing for code, just for my own sanity, having a full-time job, is to make it as pretty as possible. Does anybody here have experience with non-blocking, whether client or on the server? Okay, so 2, 3. Especially in Perl, it's not very common, so the rest of you shouldn't feel embarrassed if you even cared. But that's what this is for, to introduce you to it. And the goal here is that once you get an introduction, you'll have a taste for it, and it'll change the way you do all your applications in Perl forever. So first, we'll address the why. Going back to the idea that Node.js is fast. Maybe. You'll hear people talk about non-blocking services being fast without necessarily knowing what that means. It's just cool to say something fast, especially when you're using it. In truth, non-blocking services have nothing to do with being fast or slow. A web service can be fast, but one thing at a time doesn't really help as much. If one response is slow, then it's going to be blocking all the other potentially fast responses. You'll get lots of timeouts and lots of potentially unhappy users. That one thing can be fast all day, but if it's just one thing, there's no throughput and there's no scalability. So the goal in non-blocking applications is not speed. That's a completely orthogonal metric. The goal is scalability. We need to be able to do many things at once, each thing not interfering with the performance of the other. You can see that this one guy is really slow. It's not ideal, but it's okay because he's not getting in the way of everything else. We can address him separately, and then everything else will not come to a halt while he's being slow. So I hope you see the difference now. It's very simple, but it's important that you understand the difference between fast and scalability. It's important to understand this on an intuitive level when you're designing your applications, because it's easy to optimize for being fast. It's very clear, it's very obvious to us. Optimizing for scalability, making sure you can do many things at once, maybe it's obvious if you've had experience with it, but when you're first coming to it, it's not so clear, especially with a single-threaded language. So the first thing that people usually, well, if they came at it from a hipster perspective and they heard that non-blocking was cool and they say, oh, I need to use non-blocking services, then they're already sold. For no particular reason, but they're sold. If you're a critic, you'll hear about non-blocking and you'll say, well, why do I need to do multiple things with one process? Why can't I just fork a ton of processes, and I can receive as many as I want. And that's fine. You can do that. That's been working for a long time for most people, as most web services are pretty small or medium size. But as, I don't know if you know about the C10K problem that was introduced in 1999, but at the time, web servers couldn't handle 10,000 processes per second. There was some n-squared problems in the kernel, and it was a big problem. They've solved those, but the problem still exists. If you're receiving a lot of requests and you're just forking off a ton of processes, that's a lot of overhead for the kernel to handle. Each time a packet is received, that's a context switch for the kernel, and it has to decide which process to go to. Now, after the changes were made because of what happened in 1999, well, 2001, it's not an n-squared problem anymore. It's a constant time, but it's still a context switch. And the more processes you add, the more CPU time is lost just on routing data to your application. And in truth, Unix was never made to route data. It was originally designed by AT&T to be a control system for large, powerful telecom switches, hardware that was designed to route data. In the modern world, we've moved it all into one system, which makes it easy for programmers and easy for systems administrators, but it's not actually the ideal. It's not what Unix was optimized for. So even if you don't use the one server, you can keep adding processes, and you can just put a load balancer in front of all your servers. So if you can say do 10,000 requests at one time in, say, with a default configuration of Apache, you can just do a load balancer and spread it out to 10 different servers if you want 100,000 requests at a time. Or if your server can do 100,000 requests at a time, then you just spread it out to get 1 million. The problem with that is you spent a lot of money. You have a lot of overhead as far as systems administration. And there's an optimization that you haven't even thought of because there's a closer layer that you can optimize. In fact, you can get 10,000 requests per second in one process. So if you can get 10,000 requests in one process, then you've multiplied your capacity without adding any overhead in terms of administration costs and hardware costs. Basically, you're wasting time and you're wasting money. I just like cats, honestly. That brings me to, well, before I go into the how, I'm going to give you a demo. Because you can explain it all day, but when you really see the difference, you start to understand, wait a minute, maybe I should be doing this. So, just a key piece of advice, never do a demo during a live talk. It's a bad idea. Definitely don't depend on the internet.
Just record the demo and just play it right there.
You know, if I wasn't just finishing preparing this presentation, I would have done that. Because I honestly didn't even think of that. No, I'm with you, and I will do that. Okay, so what I have here is a slow server, something that will take 2 seconds to respond, no matter what. And what I'm emulating here is if you're using a backend that's not a database, if you're using a remote API, which that's all that I do. I rarely work with databases anymore because I'm consuming other services. And I don't want everybody to be slowed down by the one slow API call that I've made that takes 4 seconds because, I don't know, because GitHub is down for some reason. So first I'm going to run a blocking server. And I'm using Mojolicious to do this. You can do blocking and non-blocking with it. And I'm going to run a blocking client, which is going to make, we'll say 100 requests. Well, that's going to take a while. Because, yes, it's taking 2 seconds to respond. It's going to the client to the other server, and then it's getting it from the slow API, which is over here. So that's going to take a while. And that's what most of us do when we want to write a script, whether it's in production or it's just a one-off script. We get the response, we do something with it, and it takes what it takes. Maybe if we want to do multiple requests at a time, we just have multiple scripts. And we just try to optimize the backend or optimize some other system so that we can get things done quickly. That's dumb. And that's what I did for a long time before I saw the light. Now what I'm going to do is then use a non-blocking client, which is able to send out many things at once, and I'm still going to do 100. Well, you still have the same problem because the server is blocking. So it doesn't really matter what you do on the client. So now I'm going to run. Oh, this is still doing its thing, chugging along. Let's kill that. Now I'm going to run a non-blocking server. Now this is Mojolicious provides Hypnotoad, which is a pre-forking server that does all kinds of fancy things. This is just one daemon. It's the basis for the development server in Mojolicious, so it's just one process. If I run a blocking client, which is 100 requests, it still does the same thing because the client has to receive the response from the previous request before it can send off the next one. But if I have a non-blocking server and a non-blocking client, and I fire off 100 requests, well, that's pretty awesome because I got everything back in almost instantaneously, 2.3248 seconds.
You said it was one process, not pre-forking?
Just one process. It's this one right here. I know. It's awesome. I will show you the code later, but after you go through the presentation, you'll understand how it's being done. And you can see there's a little overhead. It's not C, but if you want to use C, then you've got another problem. And you can see here each of the requests is only taking 2 seconds. And then it comes back, and then the time for all of the requests are 2 seconds. And that's fine for 100, but let's do 1,000. And I just got a bunch of errors. Too many open files. Let's open some files.
Does it fork on the client?
Nope. This is why you never do a live demo. Still. Okay, well, the tough part is, even though this is on video and this is going to be on the internet, you're just going to have to believe me. Because I don't know why there are so many open files. Yeah. I've said it. It doesn't like it.
I'll bet 250 will work.
250 where? Here?
For your concurrency.
Yeah, but that doesn't show how impressive it is. We still got a couple. Yeah, that's unfortunate. So you saw 100 at one time. If you have enough open files, because you really know Mac OS X and you know how to configure that sort of thing, you can run, I was going to run 1,000, and that takes about 7 seconds. There's still some overhead, but it's not linear. Because if you run 10,000, it's 40 seconds to return all of them. And a lot of that overhead is sending off the request and the socket, not the actual throughput. So you've got 10,000 requests for just one process that come back. And most of the time that it takes is just the overhead. If I wasn't running the client on the same machine, it'd be even less. And if I had more open files, then it would be awesome. And you go, ooh, but you're just going to have to believe me. So this is the point of non-blocking. It gives us scalability. We can do everything just in one process. And Mojolicious gives you the abstractions to be able to do that very simply. You just have to change the way that you think about writing code. And that's what we're going to get to now with the how. Now, whether you're talking about Perl or anything but PHP, you were dealing with single-threaded languages, at least in their default distributions. You can run multi-threads with various distributions of like Ruby, and Python has some, I think. But pretty much most people are using a single-threaded distribution of these languages. And because we're dealing with single-threaded, we can really only do one thing at a time, regardless of what the demos show. We're still doing one thing at a time. So how do we get around that? If you guys know anything about computers, you already know about time slicing. Time slicing, if you don't know, is what your computer is doing all the time, at least within a CPU. A CPU core can only do one thing at a time. That's just a fact of nature. One thing can only do one action at a time. But your CPU is splitting them up. It's doing a little bit of one, a little bit of another, a little bit of another, and it leaves time to interweave everything in. And here's just a visualization of that. If any of you are not familiar, we have one task, splitting it into subtasks, and then other things can happen while those tasks are happening. And from the user perspective, it seems to us that they're all happening, that everything's just happening at the same time, but it's really just being split. And what that comes down to is other things can happen while each thing is waiting. Thing is a technical term, by the way. It's spelled with an accent on the I. And that's where event loops come into the picture. An event loop, probably most of us are familiar with, but it's just a construct that runs continuously, always checking to see if any work is or needs to be done. In a blocking program, you schedule something. It gets put into a queue, and it has to finish before you can add something else to the queue. And that's fine. I mean, that's what the demo where it was chugging along every 2 seconds, and that does the job. That's what most of us usually do. In a non-blocking program, you schedule something. It gets put into a queue and returns focus to you before the queue is processed. So the event loop will still process the work and handle the response when the work is done. And the event loop is where the illusion, event loop with time slicing, is where the illusion of non-blocking behavior happens. It's still blocking. You can't get around that. But we call it non-blocking because it seems like that to us. Just like in a computer, we call it multitasking because it seems like that. But really, it's just doing one thing at a time per core. Now we're doing 4 things at a time, but whatever. To give you a more concrete example, we'll do the same thing with GET requests. We'll do an HTTP GET that's going to get something from the network. And in the meantime, we can send other GETs through. And that original HTTP GET is not going to get in the way of everything else. And when it finishes, the task can be completed. And that's pretty much how it works conceptually. You can see, even though at least one person was impressed when we did all of these things at once, there's not that much to it. It's easy. You just have to understand how it's working. And what does an event loop look like? When I first started looking at non-blocking stuff, if you were to ask me what an event loop was and actually code one, I could do it. But I had this idea that an event loop was this magical thing because it lets us do all of these things, and like that's what like really cool people use in their programs, event loops. Well, there's nothing to it. It's just a loop that says, is there something to be done? Cool, do it. And then it goes on, and it keeps going over and over again. The Mojolicious event loop is more complicated than this. I just want to specify that. I shouldn't say complicated. It's more complex and more advanced. But it does the things and then keeps going and checks them. And now that we've looked at some amazing code, let's look at some more code. First, I want to start with some Mojolicious syntax. I don't know how many of you are familiar with Mojolicious. If you're using Perl, you should be. But if you're not, it's OK. You can get there, and I won't judge you. Mojo user agent. We declare an object. Pretty basic. And we have a blocking call. You give it a URL, and you get the body from the response. The non-blocking call takes a callback. And that's pretty simple stuff. Everybody who uses Perl can understand that. And when the response comes back, it executes the subroutine. The event loop executes the subroutine. And that's how you use user agent in order to do non-blocking clients. Normally, when people write a one-off script or they think of a client, they're not thinking in non-blocking terms. People sometimes think in non-blocking terms as far as the server, but not necessarily in the client. But I'm here to show you that everything you do should be non-blocking. And ordinarily, I don't like should, because it's Perl. You can do whatever you want. But my opinion is that you should be doing and thinking in non-blocking, because you don't want to run into scalability problems down the road because you didn't think about it. Normally, your blocking call is like this. We do a get, we assign it to a body, we do something with that body, and then maybe we'll render that text. And this is what we saw before. Puts it into the event loop, has to wait 2 seconds for each thing to go. And here's another way to think about it. I was told by someone that this was not very clear, so I came up with a much more interesting, I think, visualization with cats. So the cat is hungry, but there's only one bowl for the cat to eat from. So the chef gives the cat some food, and the cat eats, but he has to wait for that cat to eat in order to get to the next one. And this is blocking code. It works, I guess, but it's slow and it's cumbersome. Non-blocking is where the chef gives the cat some food, and he eats, and while he's eating, he can give the cat all the other cats' food. And when they're finished eating, they move on. So you have scalability with cats. Compare that to our blocking example. This is what most people do again. Well, this isn't going to work for us if we want to do many things at one time. You can see that the GET request has no callback in it, so it just has to wait for it to be done. We need to be able to do this. We need to be able to display lots of cats on the screen, but we also need to be able to do non-blocking and create many things at one time. So let's look at the non-blocking version. It's pretty much the same thing, and it's very simple. There's nothing complicated going on here. We have an HTTP GET, and when it returns, the event loop will fire. When it's completed, the event loop will fire the callback, which gets the body, does something with that body, and maybe renders that text. Great. We've got non-blocking code. You guys are all experts. Well, what happens if you want to do sequential things? You want to do two non-blocking actions, and you want them to happen after each other. If you were to do another GET request just underneath this, they would both fire off at the same time. And we want to be able to process both of them together. Well, you could do this. This is pretty easy. We know we can do callbacks, so we just do a GET request, we pass it a sub, and inside that sub, we do another one. And that works. This works just fine. If I knew that I was only going to do one, actually, I don't even do this anymore. I used to do this. And I thought it was cool, because I was doing callbacks and non-blocking. Well, the problem with that is if you want to do, it's only a matter of time before you, well, if it's my boss, he's going to come to you and say, that's not what I said. I said this. And it doesn't matter what he said before. It's retroactive. So I may have to do 5 or 6 non-blocking sequential calls. Ta-da! We can do multiple callbacks, and this will work. But if any of you have ever tried to mess with embedded subroutines, or really just embedded blocks of any sort, it gets kind of crazy. I personally think if you have to indent more than 3 times, for any reason, it's a red flag. you're probably not using functional style. You can do it if you want. If you have to do more than 4 times, you probably have a design flaw in your programming. You need to rethink what you're doing because it's going to be hard to read. Here, I'm just making assignments. If I'm doing actual real work, and I have, I don't know, one big embedded callback that is 1,000 lines. Okay, if you have 1,000 lines in your program, you have a problem too. But we'll just say, for example, if you have 1,000 lines, when you go to make a change, now you have to worry about scope. And you have to worry about indentation if you want to keep your code somewhat maintainable, or at least the same maintainability that it was before. And you have to, there's a lot to have to worry about. Hopefully your code editor does it. It really depends on how experienced you are, because everybody here is Perl, so you're probably using Vim or Emacs. Or maybe not, I don't know. Either way, I think I've established this is difficult. If you haven't experienced this before, you're just going to have to trust me, or trust the other people who are like, when they first saw this. So what people usually do, the first step when they run into this, like, wait a minute, I sense a problem. They say, wait a minute, I can take all the callbacks and assign them to other things, or declare them previously. So I can take, if I have 4 steps, I can take the callback 4, and I can declare that. But then you have to declare all of them. You have to declare the last step first. And then once you do that, you can declare your 3rd step, because you have to reference it. And you keep going and declaring all the callbacks until you get to the point where you're actually starting to work. This will work. It will do the job just fine. Perl doesn't care. If I'm reading your code, I care. Because now we've got code all over the place. And maybe you design code wonderfully, and you have all kinds of wonderful comments and abstractions and things that make it very easy. You can say that, but I don't believe you. If you're doing this, your code is hard to read. Because now we've got this problem because we want sequential steps, but we either have crazy indentation or we have callbacks declared all over the place with no obvious ordering. When I look at code, I don't want to understand it. I honestly don't care what your code does. I just want to glance at it so I can kind of understand what's going on. If I need to know and make modifications, then I'll understand it. But I don't care. I just want to get it done because I have other things to do than be at work. So there's no obvious ordering of steps. And this is usually what non-blocking code looks like. If any of you have used any event, wonderful framework in Perl. But it's kind of cumbersome. Once you get it, it's easy. I always understood this, but it's kind of cumbersome. So if you remember our blocking program, this is easy. It's so simple. We can look at it and see what it does. You can make it complicated if you want, but this is simple. So the application flow is very obvious. It's very explicit, but there's no scalability. And that's not going to help us because we're trying to do non-blocking code. Blocking apps tend to look more like this. And this is why people always create blocking apps. And it's taken the world at large, even in almost every language, a while to get the hang of non-blocking. We're still, as an industry, we're probably 10 years out from really being non-blocking everywhere. So we want something that gives us this explicit ordering without the indentation of callbacks and without and gives us we want something that gives us explicit ordering, but also, yeah, I guess the embedded callbacks give us explicit ordering too, but then you've got this X dimension that you have to deal with. So I want my blocking apps to look like this. Unfortunately, because Mojolicious is awesome and pretty, we give you Mojo IOLoop delay. Now this is a sexy name, I know. And that's why I made it like glitter. Barring the sexy name, if you can handle it, Mojo IOLoop delay does some very simple things to give you some extremely powerful abstractions. And that brings us to the sequentially ordered. Does everybody get the reference? Nobody gets the reference?
Something good, ugly,
The good, bad,
bad.
Yes, okay. Well, I like his answer. Something good, bad. It's kind of like a wedding. Wait, am I the ugly? Okay. All right. So this is the sequentially order. And this is what we're going to do with delay. We're going to get the benefits of the explicit ordering, and we're still going to get non-blocking. We get all the things. This is a simple example of delay. We declare it. We make our first network request. And this little guy tells Mojolicious it can go to the next step and execute this. Now, if we wanted, that's two steps. If we want to make sequential network requests, we can just do this. And this gives us the same effect as our embedded callbacks and our out-of-order declared callbacks. But it's much easier to read. We're still using callbacks, but they're all flattened. And it's very easy to read. Again, you can make it complicated. But by itself, if you don't make it complicated, it's very easy to read. You don't have to worry about all the syntax here. We'll get to that. I'm just showing you the example. 1, 2, 3, 4. It's obvious. Now compare this explicit ordering to this, and then to this, and come back to this. It's relaxing.
It doesn't show order. I mean, it doesn't have referencing to the previous data, does it? Like dollar delay.
Yeah, actually, I'm just kind of hand waving here because I didn't want to explain the syntax here. This does work, but to give you an example, the second sub where it says store equals pop-res body, that's just a shortcut for getting the body from the previous request. Don't worry about that at the moment, but that's what passes it on. You pass data from one to the other. So we have the readability of blocking code, and we have the scalability of non-blocking code, and we have that sexy name, Mojo IOLoop delay, which gives me joy. So let's take a closer look at how it actually works, because this is how I make all of my scripts and applications. Everything's a Mojo IOLoop delay because it's non-blocking and it's very easy to follow. So this is the first simple example of delay. Now, I told you that this guy told Mojolicious to go to the next step. That's not exactly true. Somewhat true, but it's not completely true. Begin is a curious little function. It's very simple, and you'll see how simple it is in a moment. But the implications of what it does are very powerful. So delay, it does two things. First, it does one thing, just accept it here for a moment. It does the first thing, and then it returns a callback. So it does a thing, and then it returns a callback. Well, remember our user agent syntax for non-blocking. This takes a callback. I bet we can use begin. Let's remove this body to simplify it. And let's look at the non-blocking syntax with begin. They're both receiving callbacks. And because the GET request receives a callback, Mojolicious knows to make this non-blocking. So Mojolicious has to know, otherwise it'll go to blocking because it defaults to that, because that's the way most people use their scripts. But what happens when begin is being called? I said it did a thing and then returned a callback. Well, this is crazy. So stay with me here. Again, this is very simple, but the implications are powerful. Begin increments a counter.
It's not very hard.
Well, it counts. That's awesome. So it increments a counter. Again, the implementation, the actual implementation is a little bit more complex than this, but this is essentially what it's doing. It increments a counter and then returns a subroutine or a callback. When the network request has completed, it calls the subroutine and then decrements a counter. So this is very simple, but I want you to get this because If you don't get it, you can still use Mojo IOLoop today very easily. But you won't be able to harness the full power of it if you don't get this simple concept.
So it's like externalizing a stack.
Yes. Yes.
Doing stack.
What we're doing is this is how promises work. Promises, and this is called the steps library. Promises and steps library are two different ways to do the same sort of thing. If you're familiar with promises. Steps libraries are a little bit more powerful. They're kind of like one tool that does all the things, whereas promises have separate tools that do separate little things. It's just a design decision. So, again, the begin increments a counter and returns a subroutine. When the network request is completed, the subroutine is called and the counter is decremented. Just to visualize it, the HTTP GET is initially made. And the reason I'm going over this so many times, in case some of you get it, is because this is the most complicated thing that a lot of people have trouble getting. And maybe it's the way that it's explained. Maybe it's just because they're not thinking in a non-blocking form. I think this is incredibly easy, but I've been using it for a long time, so I want to make sure you get it. Makes the request, a counter is incremented. When that request is completed, it calls the subroutine that decrements the counter. So, now you get it, right? No. OK.
Where did you define what begin returns?
Well, begin is an internal Mojolicious. I was kidding when I said, now you get it right. But the begin is an internal Mojolicious function that essentially makes a counter when it's called and then returns a subroutine that decrements a counter. And this is how it's used. Let's take another delay example. Delay begin returns a callback. So Mojolicious knows to make these non-blocking. This is firing, and then so it'll make the request and then immediately go to the next line. So this is making 4 simultaneous requests. When begin is initially called, when the network request is being made, the counter is being incremented 4 times. When the network request is completed, the subroutine is called, and the counter is decremented. Now, after that's decremented, that's actually how Mojolicious knows to go to the next step. When the counter gets to 0. It never, by the time it got to the 4th line, the counter has already been incremented to 4, so it didn't know to go to the next step, because it starts out that way. But we've called it, we've incremented it, and we've decremented it. You can, some people are not, this is a couple layers of abstraction, just assigning it directly. That's how it's generally used. You could assign the delay begin subroutine somewhere to another variable and call it, which is maybe how an intermediate Perl person would use it. But this, it's very simple, it's very clean. Once you understand what begin does on an intuitive level, you just do this no problem. Then, after it's been decremented,
Can those come back in a different order too? Like, so one of those requests took longer?
well, they do.
And so, but the order could be different. It doesn't have to be 3, 2, 1, right? It can be 1, 2, 3.
The way that the network, yeah, I mean, they could all come back in all different orders. What this is doing is it's not going to go to the next step, until they all come back. And then Mojolicious will put them in the right order for you.
Right, but it just how you have it in the example, though, like it could be a different order of how they're decrementing.
Yes.
3, 2, 1, 0.
Yeah.
2, 1, 3, 0.
It'll be completely random.
Where it's non-blocking that way, it's coming. It doesn't have to. It's not going to be in that order always.
Right. Or not necessarily random, but seemingly chaotic according to the network. Yes. Fortunately, Mojolicious puts them in order for you, because otherwise that would be annoying. So now we've got this sub where we've got this delay. And what we've done is we've split a bunch of things out and then aggregated them all back, which is a very important pattern when you're dealing with any kind of enterprise messaging architecture. Splitting and aggregating, you need to do that all the time. And then we can do whatever we want with these 4 transactions. And that is pretty much how begin works. And with this, I hope I've made this so simple that you look at it and you're like, why am I even here? This is ridiculous. Because that's the point. It's so simple. But with this, you can make any combination of concurrent or serial network requests or non-blocking actions. You can do anything you want. I just submitted an app to the App Store, and I'm excited. But how it's relevant is that at different points, there's going to be 2,500 to 3,000 people accessing the API that it uses round about the same time. Normally, I would have to manage a server, and it's only 25 to 3,000 requests, but I still have to make sure it's managed. I have to make sure it can handle all those. I have to go and buy a dedicated server or rent one, whatever. I don't have to do that with this. I have one free Heroku daemon that is handling all of them, because I can do whatever I want. Because I can have 4 sequential requests, and then in response to the third sequential request, I can have 50 concurrent requests fire off. And when 25 of those 50 happen, I can fire 6 more sequential requests. I can do any combination that I want with this simple tool. And it's all relatively consecutive. I mean, I can make it as complicated as I want. But it's incredibly powerful, because now I can do this with one process. If I want to have 100,000 processes, or 100,000 requests at a time, I can have 10 processes. We'll say 14 for overhead. I mean, let's go crazy and give it 14. But with a single threaded language. And I think that's amazing. I hope I've explained it to where you think, like, well, yeah, that's kind of cool. I can do that. Make your programs like this all the time. Make everything non-blocking, no matter what it does. Because then you can simply add something and do things all at the same time. And you don't need any overhead. You need nothing except a simple Perl script, whether it be a server or a client. And that's it. That's all I have to say. I hope that was useful.
So how did you get the information from the request to the second block? Does it not start with the sub?
To the second block.
The sub. Yeah. It doesn't even begin the first callback sub?
OK, so when begin is, if I understand you correctly, when begin is called, when the counter gets decremented to 0, and that happens when all the requests come back.
Starts the next step?
Then it starts the next step. Mojolicious knows to do that in the background.
How did you get text 3 and TX4?
Well, those are just arbitrary. OK, so it puts them in a list to the arguments. So those are just arbitrary variables that I've assigned, and it puts them in the order that I declared them originally. So text1 is the transaction 1 is the response to the zombo.com. Transaction 2 is the response to the zom1.com, and then so on and so on.
It will put it in the array for the next one? How does it know to do that?
It's magic. Mojolicious handles that for you in the background. Yeah.
So just to clarify, the elements that come in that array in the second sub block there, the first one's going to be the delay object, then the rest of them are going to be the return values from each delay-begin call that you issue in the previous step, right?
They're going to be the return. Yes, they're going to be the return values that's put into the sub. So it's the network. It's the response to that network request.
The begin call is what triggers that needs to get shoved into the.
Yes. Yes.
That begin is where that callback is some routine that says, hey, for the next guy, I'm going to be in there.
Right, and that's why I went over this. Like this right here is what it does. Increments it, and then calls that sub with the response from that network request. And these don't have to be network requests. That's just the most obvious and concrete way. They can be timers. They can be anything really. But network request is usually what you use them for. My API, the slow API that takes 2 seconds uses a timer that just fires something off in 2 seconds, which is essentially a sleep, but a non-blocking sleep because it doesn't block the rest of the program. Any other questions?
Okay. It seems the limiting factor then is since it's Perl, you're always using external modules as well to talk to things. And sooner or later you encounter a module that is not natively non-blocking, such as MySQL, for example.
Yes. If you're using something that's non-blocking, then it's going to block. The first thing that people do when they test out non-blocking is they say, hey, I'll just sleep. And then it'll return. But sleep actually puts the whole process to sleep. And they run into problems and they get angry. Mojo timer, if you want to look into it, is just a timer that's effectively a non-blocking sleep. When I, like the current service that I made with the app, I used Mango, which is a non-blocking driver for, it's part of the Mojolicious project, and it's a non-blocking driver for MongoDB. The trouble with DBI is that there's no non-blocking support, and that's unfortunate. You can actually make a call. You can make one call at a time after something has happened, but it doesn't like do all the cool things. I don't know. Maybe you can call Tim Bunce in Australia and get him on it. That would be awesome. The other cool thing is that this uses internal Perl, a pure Perl event loop. If EV is installed, it will use EV, which is much more efficient. If you don't know what EV is, don't worry about it. But if you do, that because it uses EV, you can also use any event. Pretty much anything that uses EV as a backend, which is anything in Perl that is non-blocking, you can use them all together. So you can use any event, the any event framework. You can use, I don't know what else uses any event because I only use this. You can use them all together in all their different glories. I find Mojolicious to be the easiest because it provides some abstractions like begin that does some things in the background that just make it easy. Because I don't, honestly, when I'm making an application, I do not care how Mojolicious works. I don't care how Perl works. I just want it to work and do all the things, and I don't want to worry about like what's going on in the background. Any other questions? Great. That either means you weren't interested or it was so simple and you got it. Cool.